Hello everyone. Good afternoon. My name is Amit Kumar. I am currently fourth year undergraduate student at Indian Institute of Technology, Kharagpur, and today in this session we will be starting with a chapter of mathematics that is binomial theorem. This is an important chapter in algebra field, and basically we'll be starting with a brief introduction of this chapter. Before starting with this chapter, a brief introduction about myself. I cleared my J Advance in 2020 and currently I'm pursuing my electronics and electrical communication undergraduate at IIT Kanpur. So I'm currently from Lucknow and today I'll be here to discuss this chapter with you all. Okay, so that's all about myself and without further delay, we'll be get started with this chapter. Okay, so yes, if I describe about this chapter, what this chapter is all about. इस चैप्टर का बेसिकली ओरिजिन होता है हमारे एक्सपोनेंशियल एक्सपेंशन से. सो लाइक इफ आई स्टार्ट विद समथिंग कॉल्ड a प्लस बी होल स्क्वायर. सो ये हम सबको काफी पहले से पढ़ाया गया. ये सिंपली होता है स्क्वायर प्लस 2ab प्लस बी स्क्वायर. ओके, ये तो सभी को पता है, बट how to utilize this for some large exponents. Let's say we are given some very big exponent, let's say a plus b to the power 5, let's say. So how to expand this? Basically, binomial was a method given to expand such kind of exponent where the exponent is very large or it might be any general exponent. Okay, so basically you have to just remember that there are two terms here, a and b. Okay, so like every term would be something form of a to the power r and b to the power n minus r. In other words, the sum of these two expand will always be equal to n. Okay, n is here any exponent of this number. Okay, and there will be some constant term c. Okay, and there will be number of terms, such terms. Okay, not a single terms. Okay, so there will be something called CI equal to 0 to n. Okay. So this is a general formula for the expression of this binomial series. Okay. So you can say there will be total n plus 1 terms for any exponent n. Okay. So like if we go with something called Pascal triangle. Okay. So the Pascal was first to analyze the coefficient relationship for these kind of exponent. Okay, like what happened? There will be some terms like some terms of a to the power 5 c1 a to the power 5 plus c2 a to the power 4 b to the power 1 plus c3 a to the power 3 b to the power 2 plus c4 a to the power 1 b to the power 4 plus c5 b to the power 5. Okay, this would be general expression of a plus b to the power 5. Okay, and these coefficient relationship are analyzed by the Pascal. So you can see here as well, like there is like this is given here, the Pascal triangle, which describe about the coefficient relationship. Okay, so but this might not be always possible to remember all these coefficient, but so there is a general formula like if you know about the concept of factorial. So these coefficient are nothing but like if you are analyzing the coefficient ith coefficient. Okay, ci, so this is nothing equal to nci. Okay, where nci is n factorial upon n minus I factorial into I factorial. Okay, so this is a general formula. Okay, so we can write a general formula for the expression of a to the power a plus b to the power n. Okay, तो इसका जनरल फॉर्मूला होगा I इक्वल टू 0 to n समेशन ऑफ n c I a to the power n minus I and b to the power I. Okay, so this is all about our general formula, how we expand our binomial. So the whole chapter is based around this expression where every time you have to just remember about this expression. Okay. and you already familiar with the concept of permutation and combination, that how to expand NCI and what are the properties of NCR. Okay, like you know that NCI is equal to NCN minus I. Okay, this is also a property. Okay, and there are some other properties also that you must have learned in the chapter, that is permutation and combination. So we'll also be revising those properties here as well. And one thing that is special to notice about is that if we expand this formula, then this will be something like NC0 a to the power n plus NC1 a to the power n minus 1 B1 plus NC2 a to the power n minus 2 B2 plus dash dash. This will be something like NCn minus 1 a b to the power n minus 1 plus NCn a to the power 0 b to the power n. Okay, or there would be no times of a. Okay, so you can see that this coefficient and this coefficient, this coefficient, this coefficient, and this coefficient, these are equal. So you can say that the coefficient which are at equidistance from beginning and have an equal coefficient. Okay, so this is an important observation, that the coefficient equidistant from beginning and okay, so ये important observation है. And there are some other observations, like if you are asked RF terms. Okay, so you can say like this is our first term, so this is our second term, this is our third term, this is our so on terms. Okay, so the RF term, the coefficient would be NCR minus 1. Okay, this won't be not, this is not NCR. Okay, RF term won't be NCR, it will be NCR minus 1. Okay, one less. Okay, so this is also. And another term is what is the maximum coefficient. Okay, so you know that in a binomial there will be terms like NC1, NC2, NC3, NC4, NC5, and so on. These would be some terms, and NC n minus 1 and C. Okay, these would be terms. Okay, so what is the maximum term? You know that this would be a some value, and the same value will also be this, and this value, and this will be value will also be same. Okay, there will be MC0. Okay, so this same, and this same. Okay, so you can assume something like this value will be firstly increasing up to certain value, and this will start decreasing up. Okay, so there will be some maximum value of coefficient in between. Okay, so this maximum value is nothing but the mid value. Okay, so like if n is even. Okay, then the maximum value will be NCn by 2, and if n is odd, then the value NCn minus 1 by 2 and NCn plus 1 by 2 both will be mm, globally maximum values. Okay, so this is also an important thing that you will need to keep in mind while doing the exercise and problems related to binomial theorem. Okay, so दिस इज समथिंग दैट कॉम्बिनेशन चैप्टर में भी हम लोगों ने पढ़ा होगा कि मैक्सिमम वैल्यू कोफिशिएंट की तब होती है जब ये जो बेस होता है इसका ये न्यूमेरिकली हाफ इक्वल टू टोटल वैल्यू. ओके, so these are the things. And if you see some expression like the illustration given here. Okay, so like if you see some illustration here, then like if you see this illustration here, like this one, okay. So you can see x plus 2 to the power 6. Here we have expanded this extension, okay. So like how we have expanded this term, okay. So you can see the coefficient, this is 60, 61, 62, 63, 64, 65, and 66, okay. And you can also observe the exponent here. You can consider x to be equal to a and 2 equal to b, okay. So this is something like a to the power 6, this is a to the power 5, b to the power 1, this is a to the power 4, b to the power 2, okay, and so on. So this is the usual way we extend the binomial terms. Okay, there are many other conclusions or relationship that you can make by using those binomial coefficient. Okay, so you know the coefficient extension of 8 plus b to the power n. Okay, this is summation of NCR a to the power n minus r b to the power r. Okay, r is 0 to n. Okay. And if you replace by minus b, okay, then this is a minus b to the power n. This is equal to summation r equal to 0 to n and c r a to the power n minus r and minus or b to the power r. Okay, so हमें पता है कि ये निगेटिव कब होगा. सो जब भी आर निगेटिव हो, आर ऑड होगा, ओके, जैसे आर इक्वल टू 1, 3, 5, 7, 9 एंड सो ऑन, ओके, ये होगा तब ये क्या होगा, -1 टू द पावर ऑड होगा एंड -1 टू द पावर ऑड निगेटिव होता है, ओके. सो the coefficient like MC0 a to the power n, and the first term would be negative, okay, and C1 a to the power n minus 1 b, second term would be positive, okay, and C2 a to the power n minus 2 b2 and minus and C3 a to the power n minus 3 and b to the power 3, okay. So and so on, okay. So you can see the terms like NC1, NC3, NC5, these term would be negative and rest of the term would be positive, okay. Or you can also say that half of the term would be negative and half of the term would be positive, okay. And here another important relationship is this is जब हम a equal to 1 assume कर लेते हैं. So this is an important relationship जो कि काफी यूज भी होगा बहुत सी जगह पे. तो इसको भी ध्यान में रखना है अपने को कि ये मतलब बहुत जनरल एक्सपेंशन है जिसमें ए को 1 अज्यूम कर लेते तो ये सिंपल एक्सपेंशन हो जाता है NC0 NC1x plus NC2 x square and so on, okay. There are some the smaller application of this binomial extension, like you can see in this example, which is larger value. So here they just converted this 1.01 as 1.01 as 1 plus, and by binomial extension we can compare which one is greater. Okay, so these are some application that will be seen in this chapter as well in the exercise part. Okay, so like if we start with the exercise part now, then let's say we expand the second question. Okay, so you know that the expansion would be there is some negative sign. Okay, so you know that the terms like NC1, NC3, NC5, these would be negative and rest of the term would be positive. Okay, so this would be something like 5C0 2yx to the power 5 minus 5C1 2yx to the power 4 and x by 2 should be 5C2 2 by x to the power 3 and x by 2 whole square, and this would be minus of 5C3 2 by x to the power 2 and x by 2 to the power 3, okay, plus 5C4 2 by x to the power 1 and x by 2 to the power 4. Okay. And this would be 5c 5 2 by x to the power 5 0 x by 2 to the power 5. Okay. So if we quickly expand this term, so this would be like 5c0 is 1, so this would be 32 to the power x by 5 minus 5c1 is 5, so this 5 into 16 by 2, okay, so this would be 40, 1 by x to the power 4 into x, so this would be x cube, okay. 5c2 is 10 and this 8 by 4, okay, so this would be 20 by x 1 by x cube into x square, so this would be x, okay. That's 5c3 is again 10 into 10 by 2, okay, so this would be 5x, and plus this would be 5 by 8 x cube minus x to the power 5 by 32, okay. So this would be complete expression of this expression. So this is the usual method. We'll be expanding the terms. Okay. So if we quickly take another question, that is, let's say question number 5. Question number 5. Then this would be x plus 1 by x to the power 6. Okay. So this would be nothing but 6c0 x to the power 6 plus 6c1 x to the power 5 into 1 by x plus 6c2 to x to the power 4 1 by x square plus 63 into x to the power 3 into 1 by x to the power 3 plus 64 into x to the power 2 into 1 by x to the power 4, okay, plus 65 into x to the power 1 into 1 by x to the power 5 plus 56 into x to the power 0 into 1 by x to the power 6, okay. So this concluded to x to the power 6 plus 6x to the power 4 plus 15x square plus 20 plus 15 by x square plus 6 by x to the power 4 plus 1 by x to the power 6. Okay. So this is complete expression of this term. Okay. एंड इसके बाद वाले क्वेश्चन पार्ट पे हम लोग को कुछ एल्जेब्रिक वैल्यूज फाइंड आउट करनी है, लाइक न्यूमेरिकल वैल्यूज ऑफ सम बिग एक्सपोनेंट. ओके. सो इस पार्ट में हम देखेंगे कैसे हम एक्सपोनेंट की वैल्यूज फाइंड आउट कर सकते हैं यूजिंग बाइनोमियल. ओके. Let's say we have to find 99 to the power 5. Okay. So we can write it as 100 minus 1 to the power 5. Okay. And now we can expand this. So this will be 5c0 into 100 to the power 5 minus 5c1 into 100 to the power 4. 1 की कोई भी पावर का वैल्यू 1 ही होगा तो उसे इग्नोर कर देते हैं. So this will be minus 5 plus 5c2 into 100 to the power 3 plus 5c3 100 square plus 5c4 this will be 10 to the power 10 minus 5 into plus 10 into 10 to the power 6 minus 10 into 10 to the power 4 plus 5 into 10 to the power 2 minus 1. Okay. So इसे कैलकुलेट करें तो ये होता है कुछ 9509004049. ओके. तो इसे आप कैलकुलेटर से भी कैलकुलेट कर सकते हैं या फिर न्यूमेरिकली एक बार यूजिंग हैंड भी कैलकुलेट कर सकते हैं. So like the same way you have to for this 102 you have to write plus 2 to the power 5, and again there will be terms like NCR 100 to the power n minus r into 2 to the power r. The summation of these terms would be your final answer. Okay. So after this, like if we try the question number 10, so like in this part you are asked which one is greater 1.1 to the power or 1000. Okay. So like in this term you can write as 1 plus 0.1 to the power 1,000. Okay, so this would be like if we write this expression in a reverse order, so this would be 10,000 C 10,000 into. Okay, let's write in a normal order only. So the first term would be 1 plus 10,000 C1. Okay, so this would be 10,000 into 0.1 to the power 1. Okay, plus there will be some other positive terms. Okay, so this would be like 10,000 into 0.1. So this would be 1,000 and plus 1. Okay, so this would be 1,001 plus some other positive term. Okay, so this will always be greater than 1,000. Okay, so you can straightforward say that this value will always be greater than 1,000. So after this, if we see the question number 11. Okay, so this is like a plus b to the power 4 minus a minus b to the power 4. Okay, so if you quickly observe this thing, then this would be like let's forget about the exponent. Let's only think about the coefficient. So its coefficient would be like 4C0, 4C1, 4C2, 4C3, and 4C4. Okay, and the coefficient of this would be like 4C0 minus 4C1 plus 4C2 minus 4C3 and plus 4C4. Okay, this would be coefficient, and there is another additional minus sign. Okay, so if you multiply minus sign inside the bracket, then this would be like minus plus, this would be minus plus, and this would be minus. Okay, and when you add these two terms, okay, so what happen after adding, you will only be getting like 2 times of 4C1 and 4C3. Okay, rest of the term will always eventually get cancelled. Okay, so the answer would be 2 times of 4C1 into a to the power 3 into b to the power 1 plus 4C3 into a to the power 1 b to the power 3. Okay, so we observe, then this should be like 4C1 is 4. Okay, so 8 times A cube B1 plus A B cube. Okay, so this would be 8 times of AB A square plus B square. Okay, and you have to observe, you have to find the value of A equal to root 3 and B equal to root 2. Okay, so if you put the value here, then this would be 8 times of root 6 into 3 plus 2. Okay, so this would be 40 root 6. Okay, this would be our answer. Okay, similarly, like in the 12th part also, like here you have to think like x plus 1 to the power 6 plus x minus 1 to the power 6. Okay, so like if you observe this term, then the coefficient like minus of 6C1 minus 6C3 minus 6C5, this will all get cancelled, and the only term should be like 2 times of 6C0 x to the power 5 plus 6C2 into x to the power 4 plus 6C4 x to the power 2 plus 6C6 into 1. Okay, so this will be final expression of these two additions. Okay, and in the last stage, you can put x equal to root 2, and that would be your answer. Okay, so we move to the question number 13 now. So this would be like you have said that 9 to the power n plus 1 minus 8 n minus 9 is divisible by 64. Okay, so you have to prove that. Okay, so if we see 9 to the power n plus 1, then this would be like 1 plus 8 to the power n plus 1. Okay, and now we can expand this terms. Okay, so this would be 9 to the power n plus 1 equal to n plus 1 c0 plus n plus 1 c1 into 8 plus n plus 1 c2 into 8 square plus n plus 1 c3 into 8 cube, and so on. And the last term would be n plus 1 c plus 1 into 8 to the power n plus 1. Okay, so if you observe this expression, that this would be 1 plus n plus 1 times of 8 plus 64 times of n plus 1 c2, and this would be more terms like and if you observe all the terms after this terms. Okay, so the 8 square will always be present. Okay, so you can take 64 common from all of them, so this would be n plus 1 c2 and plus n plus 1 c3, and जब 64 कॉमन ले लेंगे तो यहाँ से 8 की पावर 2 कम हो जाएगा. ओके, सो दिस वुड बी 8 टू द पावर 1 एंड प्लस n प्लस 1 c n प्लस 1 इंटू यहाँ से हो जाएगा 8 टू द पावर n माइनस 1. ओके, और इस टर्म को अगर कंबाइन करके लेफ्ट साइड में ले जाए तो हमारा हो जाएगा n प्लस 8 9 टू द पावर n प्लस 1 माइनस 8 n माइनस 9 इक्वल टू 64 इंटू k. ओके, वेयर जहाँ पे ये के हमारा इस पूरे टर्म्स को हम अज्यूम कर रहे हैं कि ये कोई कांस्टेंट टर्म के. ओके, so you can say that the left hand side is 64 times of something number. Okay, so this is definitely divisible by 64. Okay, So if we see the last question, that is question number 14, then it is given that you have to prove that summation of r equal to 0 to n a to the power r and cr is equal to 4 to the power n. So this is nothing but the reverse binomial formula. Okay, so if you see this expansion, then this should be like r equal to 0. This should be like 1 plus and c 0 and c1 into 3 plus and c2 into 3 square plus and cn into 3 to the power n. And this is nothing but 1 plus 3 to the power n. Okay, so this should be equal to 4 to the power n. Okay, so this was the simple proof for this, and this conclude our main exercise part. And if we quickly see the miscellaneous part as well, okay. So there are some 6 questions, and there are some good questions. So let's quickly try this part as well, okay. So like if you see the question number 1, okay, so this is said that to prove that a minus b is the factor of a to the power n minus b to the power n. Okay, so this, if you see the hint is given as well in the question, so a to the power n is given a minus b plus b to the power n, okay, and you are said to expand this, okay. So if you expand this like if you consider this term as a one term x and this some term as a y, then this would be like nc0 into x to the power n plus nc1 into x to the power n minus 1 into y and so on. The last term would be nc1 nc1 into x to the power 0 into y to the power n. Okay. And if you put the value of x and y, then this would be like a minus b to the power n plus n to the power a minus b to the power n minus 1 into b plus this would be like b to the power n. Okay. If you take minus b to the power n to this side, then this would be like a to the power n minus b to the power n is equal to, and you can say like till this term and cn minus 1, there will be a minus b into b to the power n minus 1. Okay. So in the remaining terms, like from here to here, okay, you can take a minus b as a common, okay, and the remaining would be like something called z, okay. So you can say that a minus a to the power n minus b to the power n can be written as a minus b to the power into z, okay. So a minus b is a factor of, okay. So this was the simple proof for this part, okay. So like if we see the next question, that is question number 2. Root 3 plus root 2 to the power 6 minus root 3 minus root to the power 6. Okay. Like we had evaluated this part in the above. If you see the question number 11 as well, only difference is that there are two additional terms in this part. The exponent is 6, but whereas the exponent here was 4. Okay, so there would be only one additional term. So you can see, you can do this by above method. Okay. So if we move to our next part, that is question number 3. you have to find the value of like a square plus under root a square minus 1 to the power 4 plus a square minus under root a square minus 1 to the power 4. So you can consider something like x plus y to the power 4 plus x minus y to the power 4. Okay. So the terms, the general term, the final expression would be something like 4c0 into x to the power 4 plus 4c2 into x square y square 4c4 into y to the power 4. Okay. The terms like 4c1 and 4c3 will get cancelled. Okay. So if we put the values, then this would be like a to the power 8 plus 4c2 is 6 times of a to the power 4 into a square minus 1 plus 4c2, 4c4 is 1 into a square minus 1 whole square. Okay. So this would be final extension for this question, and you can further simplify by collecting the like terms together, and you can get the final answer. Okay. For the question number 4 part, okay, so you have to find the value of 0.99 to the power of 5. Okay. So like the above part, you can consider it as 0.01 to the power 5. Okay. 1 minus 0.01 to the power 5. Okay. And after extension, you can consider it as a 5c0 into 1 minus 5c1 into 0.01 to the power 1 plus 5c2 into 0.01 whole square minus 5c3 into 0.01 to the power 3 plus 5c4 into 0.01 to the power 4 minus 5c5 into 0.01 to the power 5. Okay. But you have to find the value of terms till the first three terms. But here the terms should be like greater than 3 decimal. Okay. So you can ignore these two terms. Okay. So in fact, even in this term, the decimal would be greater than 3. So you can just consider these three terms for the answer part. So the answer would be like 1 minus 5 into 0.01 plus 10 into 0.01 whole square. Okay. So the final answer will be 0.951. Okay. So like for the question number 5 and 6, there are three terms in a binomial extension. Okay. So like till now we have just considered the extension of the terms like a plus b to the power n, but we never saw the extension like a plus b plus c to the power n. So in this question it is asked, so what we do here is that we consider something like a plus b plus c to the power n. Okay. And now you can consider this as a one term x and this as a y. Okay. So you know that the terms of the extension would be something like a plus b to the power r. Okay. So in that case, you will again have to expand this using binomial. Okay. So this is something like a binomial inside binomial. Okay. So like if you quickly see the question number 5, then this should be something like 1 plus x by 2 minus 2 by x to the power 4. Okay. So you can consider these two terms as a one term and this as another term. Okay. So if we expand, then this should be something like 4c0 into 1 plus x by 2 to the power 4 minus 4c1 into 1 plus x by 2 to the power 3 into 2x plus 4c2 plus x by 2 to the whole square into 4 by x square minus 4c3 into 1 plus x by 2 into 8 by x cube plus 4c4 into 16 by x to the power 4. Okay. Now you can extend this term separately again, and these two terms are like x square and single x power 1. So you can normally extend them rather than binomial. Okay. So like 4c0 is 1 into, and if we extend this term, so this would be like 1 plus 4 into x by 2 plus 6 into square by 4 plus 6 into x cube by 8 plus this would be 4. Okay, and this would be x to the power 4 by 16. Okay, this would be minus 4c1 is 4 into, if you extend this term again now, so this would be like 1 plus 3 into x by 2 plus 3 into x square by 4 plus x cube by 8. Okay. And after that, the term would be like there would be 2 by x multiplication, and then this would be like 6 into 1 plus 2 into x by 2 plus x square by 4 and into 4 by x square. Okay, minus of 4 times of 1 plus x by 2 into 8 by x cube plus 16 by x to the power 4. Okay. So like if we group the like terms together, then this finally comes up to the this form. Okay, so this is our final extension where we come up to. Yeah, so like in the same way for the question number 6 also, you can consider first two terms as a single term and last term as separate term, and then you can expand it that part as well. Okay, so yeah, so that's all for this exercise, and this concludes the binomial part. And after this chapter, like you'll have sufficient understanding of how to expand the binomial terms and in the use of binomial coefficient and finding the values of some big exponent. Okay, so that's all about this chapter, and we'll be meeting back in the next chapter. So till then, bye bye. Have a good day.